I'm Algebra Annie, and I am here to help you be successful in your algebra class. Try to be a rainbow in someone's cloud. Amaya Angelou. Our learning target today is I can use division properties of exponents to evaluate and simplify expressions.
So now we are doing division properties of exponents. Similar to our other lessons, before we look at a rule, I want to try and see if we can figure out without the rule, so we can see really why the rule works. So we're asked to simplify this fraction. I can see that the numerator is 3 to the 8th power. Using my semester 1 skills, I know what 3 to the 8th power means. So that means that this top fraction has 3 multiplied together 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it's a fraction, so I need a fraction line. The denominator has 3 to the 2nd power, which means 3 is multiplied together 2 times. So 1, 2. Now looking at this, I'm actually remembering my middle school rules of how to simplify a fraction. If I can see a same factor on both the top and the bottom, I am allowed to turn those into ones. So I see a factor of 3 and a factor of 3. This factor of 3 can go with this factor of 3, and 3 divided by 3 is 1. So this factor of 3 and this factor of 3, they 1 out. Well, I see another factor of 3 on the top with a factor of 3 on the bottom. So this 3 divided by 3 is 1. So these two will also 1 out. So I took 2 off of the top because there were 2 of them also on the bottom. So how many did I have left? I had 1, 2, 3, 4, 5, 6. I had 3 to the 6th power, and they were all on the top. What was left on the bottom? Nothing. Everything was reduced down to just 1. 3 to the 6th power divided by 1 is just 3 to the 6th power. So I'm done simplifying. Let's go ahead and see if we can try and do this one with our semester 1 skills. It's a fraction. So here's my fraction. X to the 5th on the numerator meant there was 5 x's multiplied together. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? Denominator, x to the 5th, meant 5 of them again. 1, 2, 3, 4, 5. Now again, fraction operations. If I see a same factor on the top and the bottom, they turn to 1. So x divided by x is 1, so these 1 out. X divided by x is 1, these 1 out. X divided by x is 1, so these 1 out. X divided by x is 1, so these turn to 1, they 1 out. X divided by x is 1, so they 1 out. I have nothing left. So 1 times 1 times 1 times 1 times 1 is 1. So I'm literally left with the answer of 1. So what rule do I think applies here? Well, looking at this, there were 2 on the bottom. Those 2 on the bottom could be taken away because there were also 2 on the top. Take away is subtraction, so it looks like I'm subtracting. Well, 8 and 2. Somehow 8 and 2 turned into a 6. Well, I know that 8 minus 2 is 6. So my rule looks like a subtraction problem. So let's go ahead and see what the book says. So the book says the quotient, which basically means a fraction problem. So here's a fraction problem. The quotient of 2 non-zero powers, meaning that my exponents are not zeros, with the same base, they both have bases of 6. This is going to equal, so if we have a problem like we did at the very beginning, this equals that base, so it's the same base, raised to the difference of the exponents, which means you're subtracting the exponents. Now, how you subtract them is important. The 7 was subtracted first, so this is the top exponent minus the bottom exponent. It's very critical that you keep those two straight. The top exponent minus the bottom exponent. And that gives you your final answer. So let's go ahead and try a couple of practice problems, see if we can do this. Okay, so our first example problem. The first thing I actually notice is that on the bottom I have parentheses. We're not able to do anything until we know what we actually have. If there are parentheses there, we don't really know what we actually have yet. So our first thing to do is to evaluate the parentheses. So we're going to leave the top alone as it is, so it's a to the 5th power, b to the 9th power. Looking at our denominator, I have an entire parenthesis raised to the 4th power. Well, if I remember from an earlier lesson, that meant everybody in this parenthesis needs to be raised to that 4th power. So this a needs to be raised to that 4th power, and that b needs to be raised to that 4th power. Everybody in that parenthesis got raised to that 4th power. So now I can go ahead and I can see there are no parentheses left. So now I can go ahead and apply this rule. I see a same base of a on the top and a same base of a on the bottom. So according to this rule, if I took that base of a, the top exponent minus the bottom exponent, now I'm going to look same bases of b's. So here's my base of b. the top exponent minus the bottom exponent. So finishing simplifying, I have a to the 5 minus 4 is 1. B to the 9 minus 4 is 5. So I have a to the first, b to the fifth. None of my exponents are negative, so there's nothing to simplify there. There are no numbers to simplify. I am done. So let's look at the next problem. I see a base of 2 and a base of 2. Now this 2 should have an exponent. Every variable and every number always has an exponent. If there isn't one there, it's because it was a 1. So looking at this, I had same base of 2's. The top exponent was a 3. The bottom exponent was a 1. The rule was to subtract. I see same base 3's. So here's my same base of 3. Top exponent was a 2. Bottom exponent was a 4. The rule is to subtract. These are multiplication problems, so you need to put multiplication sign in between. And now I'm multiplying that by same base of 5's. The top exponent was a 7. Subtracting, the bottom exponent was a 5. So what do we really have? I have 2 to the second power times 3 to the negative second power times 5 to the second power. Now looking at it, we need to finish simplifying it. I know I am not allowed to have negative exponents, so he needs to go to the other side of the fraction. So I actually have 2 to the second power times 5 to the second power all over this 3 to the second power now needs to go onto the bottom. So I have finished applying my rule, but you need to do the algebra and you need to simplify it because these are all small numbers that everybody should know. 2 to the second power is 4. So this is 4 times 5 to the second power is 25. It's a fraction, so there's my fraction. 3 to the second power is 9. Now you need to finish solving this. You know what 4 times 5 is. So the top is actually 100. The bottom is actually a 9. So you have 100 over 9. And you're done. Okay, let's practice 2 more times applying that rule. Over here, first things I see, I actually have a parenthesis. I do not know what I have because of the parentheses. So my first job is to take care of the parenthesis. There was no parenthesis on top. The top stays the same. I need to figure out what this parenthesis is, and then whatever that answer is, it's multiplied to n. So to figure out this parenthesis, I see the exponents are actually touching each other. This is m to the whatever 5 times 2 is, because you multiply them. And don't forget, this whole thing was multiplied by n. So what do I really have? The top was m to the 5th, n to the 4th. The denominator was m to the 10th, n. Now, n should have an exponent. Every variable and every number has an exponent. If it's not written, it's an exponent of 1. So now I see same basis of m's. So here's my same base of m. If it's in a fraction form, you subtract the top minus the bottom. Same base of n's. Here's my same base of n. Subtract the top minus the bottom. So I have m to the negative 5th, n to the 3rd. Now you're not allowed to have negative exponents. So you need to finish simplifying. N to the 3rd was happy where it is, leave it alone. M to the 5th moves to the other side of the fraction, and you're done. Our other one, I see same base 3's, everything has an exponent. Same base 2's, everybody had an exponent. Same base 4's, everybody has an exponent. So let's go ahead and try it. Same base 3, top exponent minus the bottom. Multiplied by same base of 2's, top exponent minus the bottom. Times same base 4's, top exponent minus the bottom. So for my base of 3, 5 minus 4 is 1. Times my base of 2, 4 minus 2 is 2. Times my base of 4, 3 minus 6 is a negative 3. I'm not allowed to have negative exponents, so you need to move them. So the top was 3 to the first power times 2 to the second power, all over. The bottom is actually now a 4 to the third power. There are no other negative exponents. So now you need to finish simplifying by actually finding out the number, the values. 3 to the first power is 3 times 2 to the second power is 4 all over the bottom. 4 to the third power is 64. Now what is 3 times 4? 3 times 4 is 12. So I have 12 all over 64. If you can simplify these numbers, you need to. 12 and 4 both have a common factor of 4. So we divide both the numerator and the denominator by 4. And I end up getting 3 over 16 as my final answer. Nothing else goes in, so we're done. Now, how do you apply this rule to a problem in scientific notation? I have a scientific notation problem being divided by another scientific notation problem. Well, all the rules we've been dealing with have been written out in fraction form. So write this one in fraction form. This is the first scientific problem. he is divided by the other scientific problem. So now it looks like the fraction form problems we've been doing. Now instead of x's, we like to write multiplication so we don't know that it's actually an x. So here is my problem. Now if you have a fraction, we can split this fraction apart. So here is your plain old numbers. So here's my plain old numbers being multiplied by base of 10s and the base of 10s. What is 2 divided by 8? I know 2 divided by 8, and because it's scientific notation, you are now officially legally allowed to use decimals. 2 divided by 8 is 8.25. This is multiplied by same base of 10s in fraction form. Use the rule we just learned. Same base of 10s. You can subtract top minus the bottom exponent. So this is a 0.25 being multiplied by 10 to the third power. Now, if it's a scientific notation problem, your job is to make sure your final answer is in scientific notation. We solved this problem. He's not in scientific notation. We do not have a digit before this decimal. So that means this decimal needs to be moved. It needs to move one more this way. So I need 2.5. Scientific notation's an x. This is 10 to the... Okay, we now need to officially change this exponent. It's not a 3 because we changed the place value of the decimal point. So originally, this exponent right here is a positive 3, which meant this number is supposed to be getting bigger than 1. We just got one more step closer to bigger than 1, which means we don't have to do as many movements, which means we already did 1. So it's now a 2. So this is now in scientific notation, and you're done. So this is supposed to be a new rule. It's not. You know this rule. This is just the first time you've seen it applied to a fraction. So using a rule that we've already learned, what do you do if you have an entire parenthesis raised to the third power? You have learned that everything in that parenthesis gets raised to that power. It's the same rule. So yes, everything in that parenthesis needs to be raised to that power. Everything. So anything that happened to be in the top of the fraction, in the numerator. So this 3 gets raised to that third power. Everything that happens to be in the denominator also gets raised to that third power. Everything in the parenthesis gets raised to the third power. So now we need to finish simplifying it. 3 to the third power is 27. 4 to the third power is 64. 27 and 64 do not have a number in common, so you further simplified it, and you're done. Let's go ahead and apply it to this one. Everybody in this parenthesis gets raised to the third power. Everybody, which meant that 2 got raised to the third. This x got raised to the third. This y got raised to the third. This z got raised to the third. Everybody gets raised to the third. So looking at just the numerator of the fraction, the 2 got raised to the third. That x to the third got raised to the third. This y got raised to the third. That z got raised to the third. Everybody in the fraction gets raised to the third power. So let's see if we can finish simplifying it. What is 2 to the third power? That's 8. This has parentheses. My exponents are next to each other, which meant I was trying to multiply my exponents. Y to the third is already y to the third. Z to the third is already z to the third. So we just need to finish simplifying him. We have 8x to the 9 all over y to the third, z to the third. There is no numbers on top and bottom to try and simplify, so their numbers are fine. There's not the same bases of variables on the top and the bottom, so there's nothing else to simplify. There are no negative exponents, so there's nothing to simplify. So we're actually done, and that is it. So let's go ahead and take a look. Does the book have anything special to say? It says a quotient, which was a fraction, if it is raised to a positive power, then that is going to equal that quotient, the quotient of each base raised to that power. And it's the same thing that we already knew. We discovered it on our own. Everything in that fraction, everything in the parenthesis, got raised to that power. So let's go ahead and try a couple more practice problems. So everybody in the parenthesis, whether it's on the top or the bottom of the fraction, numerator or denominator, everybody gets raised to the second power. So this 2 to the third power is going to get raised to the second, and this 3 to the second power is going to get raised to the second. Now if they're close enough to touch like that, we know we multiply. So this numerator is actually 2 to the whatever 3 times 2 is. Look at the bottom of our fraction. They're close enough to multiply. So this is actually 3 to the whatever 2 times 2 is. You need to finish it. So we actually have 2 to the 6th all over 3 to the 4th. You know these. These are small numbers. You should be able to do them. 2 to the 6th power is 64. 3 to the 3rd power is 81. And you see if any of them have anything common, so we can simplify our fraction further. 64 and 81 do not have anything in common, so that is in simplest form, and you are done. Let's practice our next one. Everybody in here gets raised to the 5th, so that A is raised to that 5th. That B to the 4th is going to be raised to that 5th. Everybody in the numerator got raised. Now looking at the denominator, that C to the 2nd needs to be raised. That D to the 3rd needs to be raised. Everybody in the denominator is going to get raised. So I end up having A to the 5th. This is B to the, I'm supposed to multiply those exponents. Denominator, supposed to multiply those exponents. Most supposed to multiply those exponents. So I have A to the 5th, B to the 20, C to the 10, and D to the 15. Double check, did you simplify everything? Nothing is a negative exponent. You do not have common bases on the tops or the bottoms, so you're further simplified, and you're done. Let's go ahead and do our next one. Everybody is raised to the 3rd. So looking at the numerator, that A to the 3rd needs to be raised, and that B needs to be raised. Looking at the denominator, that A to the 2nd needs to be raised, and that B to the 2nd needs to be raised. Everybody in here is raised to the 3rd power. If they're close enough like this, we're supposed to multiply. So it's A to the whatever 3 times 3 is. B to the 3rd was already simplified. Their exponents are supposed to be multiplied. So this is A to the 2 times 3. Exponents need to be multiplied. This is B to the 2 times 3. So I end up having A to the 9, B to the 3, all over A to the 6, B to the 6. Now I see same bases on the top and the bottom, which means I need to finish simplifying this. So if it's same base on top and bottom, that's the subtraction rule. So same base of A, supposed to do 9 minus 6, times same base of B, top minus the bottom. So I actually have A to the 3rd, B to the negative 3rd. I see I have a negative exponent. You need to finish simplifying it. Finish simplifying this, you're going to get A to the 3rd all over B to the 3rd. And then you're done. So we technically have one last rule we need to go over. But again, you know this rule. We've learned it. If the entire parenthesis is raised to a negative power, what does the negative power mean? The negative power means that it's unhappy. If you have an entire parenthesis with fraction inside raised to a negative, that means everybody in here was not happy where they were. The 2 was not happy in the top, which means he should go to the bottom. That meant the 5 was not happy in the bottom, which meant he should have gone to the top. So if everybody's unhappy, you need to move everybody so everybody's in their happy places. And if everybody moves to the other side so that they're now all in their happy place, we now have a happy positive power. Now it looks exactly like the problem we just did. Everybody in here needs to be raised to the 3rd power. So everybody in here gets raised. The numerator gets raised, and everybody in the denominator is going to get raised. So 5 to the 3rd power is 125. 2 to the 3rd power is 8. Do 125 and 8 have a factor in common? They do not, so we are done. Going over our next one. The entire parenthesis is raised to the negative power, which means everybody in this parenthesis, everybody, is on the wrong side of the fraction. So you need to switch. So the y to the 2nd wants to be on the top instead, and now this 3x wants to be on the bottom instead. Everybody switch places, so now you have a happy positive power. Now it's our other rule. Everybody in here is raised to that power. Everybody in here gets raised. So that y to the 2nd is going to get raised. This 3 is going to get raised, and that x is going to get raised. Everybody gets raised. So our numerator, if they're that close to touch, they multiply. 3 to the 3rd power is 27, and x to the 3rd is only x to the 3rd. So what do we actually have? We have y to the 6th all over 27, x to the 3rd all in the bottom. No numbers in common to try and simplify. There are no negative exponents, and there are no same bases. So there's nothing to simplify further. We're done. So let's go ahead and see if the book has anything different to say about it. So according to the book, the rule is a quotient, so a fraction, raised to a negative power, It is the reciprocal, which meant you flipped it. Raised to the positive power. And so it's exactly what we've been doing. So let's just keep practicing it then. So this entire parenthesis, this entire fraction is not happy. So that meant everybody in here needs to switch places. So everybody switches places. It's now a happy positive power. This entire parenthesis is raised to a negative. Nobody in here is happy either. So everybody in there needs to switch places. And when they switch places, it is now a happy positive power. Now I see that I have an entire parenthesis raised to the first power. And that's multiplied by this entire parenthesis raised to a second. I need to see what each part is, so I can actually see what I have. Figure out the parentheses first. So that meant this is 4 to the first, and this is 3 to the first, multiplied by, everybody in here is going to get raised to the second. So this is 3 to the second, y to the second, that 2 is raised to the second, that x is raised to the second. So let's finish simplifying it. I have 4 to the first power, which is a 4. If you're multiplying, you can multiply straight across. So we're going to make it one big fraction. Multiplied by 3 to the second power is 9. Y squared is already simplified. 3 to the first power is 3 times 2 to the second power is 4. Multiplied by x squared. So I got to finish. 4 times 9 is 36. Y squared is already y squared. All over. 3 times 4 is 12 times x squared is just x squared. 36 and 12 do have a number in common. I can divide both by 12. Divide both of these numbers by 12. I end up getting 3. The y squared stays. 12 divided by 12 is 1, so that's an x squared. 36 and 12 were both had factors of 12 in common, so I divided both by 12. Not same bases, so those are taken care of. Nothing has a negative exponent, so everybody is simplified, and you're done. My next problem. Everybody in this parenthesis is raised to the negative power. Everybody in here is on the wrong side of the fraction. So everybody in here needs to switch places. So everybody is going to switch places. Oops. Happy positive power. That meant everybody in here is raised to the third power. So this 3 squared is going to get raised to the third power. And this 4 is raised to the third power. If they're close enough like that, you're supposed to multiply. So this is 3 to the, whatever 2 times 3 is. What is 4 to the third power? 4 to the third power is 64. So look at the top. I actually have 3 to the 6th power all over 64. Finish simplifying. What is 3 to the 6th power? 3 to the 6th power is, this is 729 all over 64. Now simplify it and you can. Do 729 and 64 have a factor in common? No, they don't. So that's actually in simplest form, and you're done. So our last two practice problems of the day. We have an entire parenthesis raised to a negative power. This means nobody in here is happy. So that means everybody in here needs to switch places. So go ahead and switch places with everybody, and now it's a happy positive power. Now we know that if we have an entire parenthesis raised to the fourth, everybody in that parenthesis is now going to get raised to the fourth power. Everybody. So here's everybody raised to that fourth power. Now if the exponents are close like this, we multiply. So this is actually b to the whatever 2 times 4 is. Close enough to multiply. So c to the whatever 3 times 4 is. On my denominator, 2 to the fourth power is 16. And that is just an a to the fourth. So this is b to the 8th. That is c to the 12th. All over 16, a to the fourth. Now see if you finish simplifying it. I don't have a number on top to simplify with 16, so my numbers are good. I do not have any negative exponents, and I do not have any common bases. So I am fully simplified, and I'm done. Very last problem. I see this entire parenthesis is raised to a negative power, which means this entire parenthesis is not happy. It means everybody in that parenthesis needs to switch places, and it's now a happy positive power. Multiplied by, this entire parenthesis is also raised to a negative, which means nobody in here is happy. So you need to switch places with everybody in there. So everybody switches places. Happy positive power. Now I see an entire parenthesis raised to a power. That meant everybody in that parenthesis is going to get raised to that power. Times an entire parenthesis raised to a power. That meant everybody in that parenthesis is going to get raised to that power. Now if I'm multiplying two fractions, you can actually just multiply straight across. So we're going to write this as one giant fraction problem. 3 squared is 9. times t to the first is t to the first. Tops are done. Bottom, s squared is just s squared, times 9 to the first is 9, times close enough together means they multiply, so s to the whatever 2 times 1 is. So 9 times t is 9t. All over, I have s squared times 9 times, this is actually s squared. Looking at my bottoms, I have the same base s with the same base s, so I need to finish simplifying it. So the top is 9t. Put the 9 in the front. Looking at same bases of s, if they're the same bases, you're supposed to add their powers. So this is actually 2 plus 2. So what do I actually have? I can finally see I have 9t all over 9s to the fourth. What is 9 divided by 9? 9 divided by 9 is 1. So these actually 1 out. So I have t all over s to the fourth. Not same bases. There are no negative exponents. So it is finished, simplified, and you're done.
What did we learn today? I can use division properties of exponents to evaluate and simplify expressions, and I look forward to seeing you tomorrow in class.